Hi students, today I am going to explain what are E1 and E2 elimination reactions and their mechanisms. So before discussing this, first we will discuss what are the basic concepts behind this. So first we will discuss what is addition reaction. So when an unsaturated compound like ethylene we take and it is added with hydrogen chloride, so alkyl halide, we will get a saturated compound. So because here a hydrogen and chlorine are added, it is called addition reaction, and here unsaturated compound is converted into saturated compound. In an addition reaction, unsaturated compound is converted into saturated compound. Then, what are elimination reactions? First, I will explain it with one example. So, first we will write an saturated compound, a saturated compound like CH2, Cl, H means CH3, CH2Cl. So, here a weak base. So, the elimination reactions are done with a weak base. When a weak base is taken, then what happens? It will be converted into a unsaturated compound. Later we will discuss its mechanism and its steps. So in the elimination reaction, what is going on? A saturated compound is converted into an unsaturated compound. So here H, why I wrote, instead of writing CH3 and CH2Cl, why I wrote up means these are removed or eliminated. So here H is eliminated and here Cl is eliminated and HCl is eliminated totally. So in the presence of weak base. So elimination reactions, saturated compound is converted into unsaturated compound. So we can define an elimination reaction like a type of organic reaction in which two substituents are removed from a molecule in one or two steps. So these two substituents can be removed in one or two steps. Depending on it, it is two types, E1 and E2. What is E1? Unimolecular reaction, elimination reaction. E2 is bimolecular elimination reaction. Then why we should study these elimination reactions? So I already told we have to study the elimination reactions to convert a saturated compound to unsaturated compounds, and also we can say that these are endothermic reactions. What are endothermic reactions? It require more heat, it take heat. So endo means taking off, thermic means heat. So these reactions require heat. So it is favorable in high temperatures. So these elimination reactions are favored at high temperatures. It occurs above 50 degrees centigrade. So if the temperature is more than 50 degrees centigrade and along with it a base is required. So these are the conditions for elimination reactions. Now we will study about E1 reactions. So let me explain. So E1 elimination reactions, we will study it about it detailedly. So it occurs, I already told, elimination occurs above 50 degrees. So it occurs at high temperature and it requires a weak base. So what are the conditions for E1 reaction? We can tell it occurs above 50 degrees and it requires a weak base. So I will explain how it occurs. Let me write. Take one example, RCH2, CH2X. So when we take like this, so this is alpha, this is beta carbon. So this is alpha carbon and this is beta carbon. So what happens in the first step? So in the first step, from the alpha carbon, X will be removed, forming a carbocation. So first step is RCH2, elimination of first, this one halide. So to form a carbocation, so charge will come. So here the first step is formation of carbocation. Then what is the next step? So here X, because it is removed. The next step is RCH2. I am writing the same again to explain the next step. Here what happens? OH. So where is OH? Because we are making it with a weak base. Here we are taking weak base. So in that base OH is there. So maybe it may be KOH or NaOH, like that. So this OH will attack the beta carbon. This will attack the beta carbon, and it will remove this H. So beta carbon's H will be removed. So it will form RCH double bond CH2, which is nothing but unsaturated compound which we get, and water is removed. Yes, no? So H, OH. So OH plus H is nothing but H2. So like this water is removed. So the E1 reactions are happening in 2 steps. So E1 reactions are happening in 2 steps. And we have to remember one thing, beta H is must. It is compulsory. Without that, elimination reaction will not take. So beta H, this one is more important for the elimination reaction to occur. So now take one example. So I am taking tertiary alkyl halide to explain this. So CH3 tertiary alkyl halide I am taking. So in the presence of a weak base CH3OH, so what is going on here? CH3 X is removed, and here one H is removed, HX is no, and with the help of here, this is alpha carbon, this is beta carbon, OH is attacked here to remove water. So water is removed, and this X is also removed. So X minus. So we will get double bond. Double bond CH2. One H is removed. So we will get like this. So this is a unsaturated carbon compound we got. So this is one example of E1 elimination reaction. Next. So we will see what is the mechanism of E1 elimination reactions. Mechanism. So I already told there are 2 steps. So first step is formation of carbocation. So formation of carbocation is the first step. So let's see the first step. Here this is a very slow step. So I am taking the tertiary alkyl halide only, the example to explain this. So tertiary alkyl halide. So tertiary alkyl halide. So I told it is a slow step. So here halide will be removed to form carbocation. So CH3 plus X minus, it will be removed and it will form carbocation plus charge. So then second step is attack of nucleophile. So nucleophile will be attacked, and this is a fast step. Let me explain that. So here the attack of nucleophile to the carbocation is the second step. Here beta carbon should be attacked with the OH minus group present in the alcohol. So it will form CH2, double bond is formed, CH3 and water is removed. So these are the two steps. So what is its molecularity? So molecularity, when we take, it is 1. So molecularity of this reaction is 1. And how many steps? I already told it is containing 2 steps. And the nature of the solvent involved in this is nothing but polar solvent is involved, and alkyl halide, which is favorable here, is nothing but tertiary alkyl halide, which we already took that example only. So tertiary alkyl halide. And order of the reaction. What is the order of the reaction? Here it is the first order reaction. Why means the order is determined by the slow determining step. So in the slow determining step, the only depends on the alkyl halide, and it will not depend on the alcohol which we are using. So it depends only on the Rx. So order is 1. Then we can say tertiary alkyl halides are more stable. So that's why the reaction will be taken more with the tertiary alkyl halides than secondary than primary. So this is the order of the reaction. Then when we compare with elimination reaction with the SN1 reaction, we can say they both have same mechanism. So when we take nucleophilic substitution reaction and elimination reaction, these two have same mechanism, and we can say one difference. What is that? At high temperatures, I already told that elimination reactions takes place at high temperatures. So major products will be E1 and so many little products, minor products will be SN1. So at high temperatures, major products will be E1, minor products will be SN1. And at low temperatures, here high temperatures means greater than 50 degrees centigrade, and at low temperatures maybe less than 25 or more than 25, major products will be SN1 and minor products will be E1. So major SN1, minor. So we can easily differentiate whether it is a E1 and SN1 by seeing its temperature first. So let me explain it with one example. So I am taking one example. So CH3, CH3. Here we can tell this is alpha, this is beta, and this is also we can consider at beta. Then when we take at CH3OH at 70 degrees, so at high temperature more than 50, so what we can say, it is a E1 reaction. So what is formed? CH3 CH double bond CH2. Yes. Then one more I will give, CH3 CH3 Br in the presence of CH3OH at 15 degrees. So below less temperature it is a SN1 reaction. High temperature it is a E1 reaction. So what is going on here? So CH3 CH3 and CH3 is formed. Here Br will be removed, and so we should remember here in the SN1 reactions this halide will be removed, and in that place CH3O will be attached to the alpha carbon atom. So that is the trick to find out the difference between E1 and SN1 reactions. So to understand more, one more example I am going to give. So what is this? So here CH3OH at 90 degrees. So 90 degrees means again E1 reaction. So first see the temperature. So confirm what it is. So what happens here? B, here H. So what is there? It will be gone from this place. This is alpha, this is beta carbon. So what we'll get? We'll get a double bond instead in the middle. So this is even reaction. So when they gave the same like that and they gave temperature less like CH3OH 10. So what we'll get? So here what happened? Br is removed from alpha carbon atom, and from here the CH3O will be attacked the beta carbon. So what we'll get? Just at alpha carbon atom only. CH3O at alpha carbon atom only. So we'll get O CH3 no double bond. So it is SN1. So like this we can differentiate between E1 and SN1 reactions. And the next video I am going to explain what are E2 reactions and their mechanism and its molecularity, how it is going on. Thank you.